Take a moment to read the question. So a hyperbola passes through the given point P and has foci at plus minus 2, 0. The tangent to this hyperbola at the point P passes through which of the following points? How do we do this question? First of all, we know that the x coordinate of the focus is given by AE. So AE should be equal to 2. We can square it to get this. Now in a hyperbola we know that b squared is equal to a squared times e squared minus 1. So we can expand the right hand side, and therefore b squared is equal to 4 minus a squared. Now let us start with the standard equation of the hyperbola. It passes through the point P, so we can plug in to get this condition. But then b squared is equal to 4 minus a squared. So we get this equation. Simplifying the equation, we get this. Now opening the brackets, we have this condition. So taking the terms to the left hand side, we have a quadratic equation in a squared. It can be factored like this. So we have two possible values for a squared, 1 and 8. But 8 would make b squared negative. So we just take a squared equals 1. So then b squared turns out to be 3. Therefore the equation of the hyperbola would be this one. It passes through this point, and at this point we need a tangent. So the tangent equation would be given like this. Over here we have used the fact that if we have a hyperbola in this form, then the equation of the tangent at the point x1, y1 is given by this formula. So we need to simplify this equation. We get this. Further, we can write it down like this. Now we need to check which among the given options satisfies this equation. So we plug in this point and we find that we have this one on the left hand side, and that simplifies to this, which is equal to the square root of 3. And that's exactly what we have on the right hand side. Therefore this point satisfies the equation, and the correct answer is option 1.